the heading of preparation haloarenes?
Yes.
Yes.
Okay, let's start with then direct halogenations. I think so we have discussed that. Let's go for diazonium salt. See, diazonium salt is very important, very unstable, but at the same time is useful to prepare many compounds. Even the dyes you will see, many of the dyes are prepared from we call diazo compounds. They give definitely beautiful colors. So in this, for preparing diazonium salt, we required an aniline. So aniline, when treated with sodium nitrite in presence of concentrated hydrochloric acid, you can take at 273 to 278 Kelvin, that is 0 to 5 degree, in a cold condition only. When we say concentrated hydrochloric acid, does not mean a very highly concentrated. Clear? Let's say I have aqueous, even you can use 5 molar, will do. So sodium nitrate, when treated with hydrochloric in presence of aniline, leads to formation of diazonium salt. See the positive charge on the nitrogen attached to the carbon of the benzene ring. So this diazonium salt, if you made to react with cuprous chloride with hydrochloric acid or cuprous bromide with the what? Hydrobromic acid, it results in the formation of chlorobromoarenes. This reaction of treating cuprous chloride with hydrochloric acid or bromic acid comes under Sands-Mayer reaction. We call them as Sands-Mayer reaction. This reaction is improved, that you will see in our minds that instead of using cuprous chloride, you can just use the copper. But now the Sands-Mayer reaction, you have to use cuprous chloride with hydrochloric acid. No mechanism, nothing we required. Please, the preparation of diazonium salt, also no mechanism we expect here. It's not easy, so that's why no mechanism expected. Just you should know the condition under which the benzene diazonium chloride is prepared. So whenever you use benzene diazonium chloride, 0 to 5 degrees is important. Once this benzene diazonium chloride is prepared, in the cold condition only you are treating with the cuprous chloride, the hydrochloric acid. Now, if you warm potassium iodide with benzene diazonium chloride, leads to formation of iodobenzene with corresponding potassium and nitrogen is given off. Same way, when benzene diazonium chloride treated with sodium fluoroboric acid, so you result in the formation of your what? Fluoro compounds. The sodium borofluoride clear compounds, that gives me fluoro compounds. This reaction not shown in your textbook, you will be learning later. So 3 reactions are very important. How to get chlorine on the benzene, how to get bromine on the benzene, how to get iodine on the benzene. So when you're learning, you will learn this way. If a compound is given to you as a benzene, how will you convert into chlorobenzene? So what we needed, we just needed then, yes, don't write a Sands-Mayer reaction or write the conditions, but remember the way. Now, if the question asks, how will you prepare benzene from ethyne? Yes. Anyone remember this?
So by heating the rod,
Yes, and yes, 560. So this is where you have to remember how benzene obtained from this and how benzene can be converted into chlorobenzene, bromobenzene, iodobenzene, fluorobenzene. No need to take stress. Memorization requires the condition. Under what condition you will get what. And same time, remember the byproduct.
So conditions as in the compound which we use now, like copper chloride.
Yes, cuprous chloride, this is what, see, if you stick to your textbook, if textbooks mention some conditions like temperature, you will write. If the temperature is not there, but you see a reference book or some other book clear, they give temperature over there. So there are many things we can give here. It's not like you carry out by simple doing this. There are many precautions to be taken.
Okay, sir.
That is not required. Here you are not learning that how actually the reaction being carried out in so many what conditions. Here we are learning that can we convert this given compound to our requirement? Yes. So what is the main component, clear main condition that we are writing here? So please do not write any other condition other than your textbook mention. Okay. Suppose if you
Yes.
write 30 degree, a reference book says 30 degrees Celsius. But if we cross check with the standard books, because reference books also been written, and if there is any mistake, you will lose entire marks then. Though we not expected from you, but since you have knowledge, you must have referred to those and written and found incorrect, then marks is lost. Okay, writing is not an issue, but same time see to that it should be standard book.
Yes, sir.
Next comes physical properties of haloarenes. The melting and boiling point of are nearly same because they have the same what chlorobenzene, bromobenzene, all those. Only important is symmetrical. Let's say example, I have taken 2-chloro, 1,2-dichlorobenzene, para, 1,4-dichlorobenzene, and 1,3-dichlorobenzene. Now if I compare, which will have high melting point?
First one.
If I say first one high melting point, then melting point means we have to think about
so
solid.
second one.
Yeah. The reason is symmetrical. Whenever melting point is concerned, we want the groups attached to the main structure should be far away from each other. Should be highly symmetrical. Then only it is possible. So symmetrical 1,4-dichlorobenzene most symmetrical compared to 1,3 and 1,2, therefore it will have high melting point. When we talk about the boiling point, then we talk about your what dipole moment. If the dipole moment, if a dipole moment is high, intermolecular force of attraction will be high, and as a result of this, boiling point will be high. So which one of this will have a high boiling point?
First, sir.
First one.
Yes. It will be 453 Kelvin. It will be high dipole moment. So this is what the melting point of haloarenes and the boiling point. Coming to the chemical properties of haloarenes, they do not undergo new. Yes.
So for the physical properties of haloalkanes in the boiling point, so the boiling point was more uh, For I guess because the Van der Waals force of attraction was greater. So, sir, is wonderful force of attraction greater or the dipole attraction?
Dipole, beta. Hierarchy, always remember your IMF. Those who want to write, they can write IMF divided into two major. One is your hydrogen bonding and another is van der Waals forces, which further divided into three categories. One is your dipole. Second, your what induced dipole, and third is the instantaneous or dispersion forces we call London dispersion. Out of these two, leaving this induced dipole, you should know dipole and dispersion. So whenever I'm talking about any polar molecule, I means dipole. If I means methane, butane, bromine, that means non-polar molecules, I'm talking about dispersion or London forces. That is one and the same. And whenever I'm talking about the molecule containing nitrogen, fluorine or oxygen, like hydrogen fluoride, alcohol, acid, clear, then we are talking about even water, hydrogen bonding. Whenever amines, primary amines, secondary amine, tertiary amines, all are related to hydrogen bonding.
Sir, but it is written that HF RCl is less than RBr and RBr is less than Ri in boiling point. That means Ri has the highest boiling point because with the increase in size and mass of the halogen atom, the magnitude of van der Waals forces of
Correct.
attraction increase.
Yes. But see, when we talk on hydrogen bonding, we need what this HF molecule. We need very high polarity. I'm not talking about the alkyl fluoride. Okay, hydrogen should come between the
Yes.
two electronegative atoms. This alkyl fluoride is a polar molecule, but the polarity difference is not very large as compared to hydrogen fluoride.
Okay, sir.
Now, coming to the chemical properties of haloarenes. Now, normally you remember substitution reaction of always proceed. Substitution reaction of your normally haloalkanes are easy because the carbon atom is sp3 hybridized. But in case of haloarenes, the carbon atom here is sp2 hybridized. So because of this sp2 hybridized, it leads to what? Double bond character. Strong bond. Percentage of S character is more. And same time you can see the resonance. The electron, non-bonding electrons on the chlorine, bromine or iodine as like X here, you will see the electrons undergoing delocalization of the ring, and that will result in the partial double bond character. Further, percentage of S character is more in sp2, so it is difficult to break the carbon halogen bond, and therefore under normal condition you cannot substitute clear halogen easily. It does not mean that you cannot carry out the substitution. Yes, but for this you require harsh conditions, very high temperature, very high pressure. So they may ask you a very simple reasoning question. Comment on the reactivity of haloarenes compared to alkyl halides, or why aryl halides are less reactive compared to alkyl halides. For 2 marks, 2 reasons you can give: due to resonance effect, due to what? sp2 hybridized carbon, double bond character. But same time, if you can draw this resonance structure, is well and good. For 2 marks reasoning, no need to draw, because any mistake in not writing the charges will be losing then 1 mark straight. Now, this is a hybridization, sp2 and sp3 only. Normal alkyl halides sp3, so the bond length is what? Longer as compared to the carbon halogen bond in haloarenes. Shorter bond, high energy. Multiple bond, large amount of energy is required to break. Suppose even if substitution take place, or chlorine will go with the bonding pair of electron, then it leads to what? Positive charge on the carbon, and positive charge cannot be stabilized. The phenyl cation form result of a self-ionization, which is also not stabilized by resonance. So this is what the difficulties, that why haloarenes do not undergo nucleophilic substitution easily. But at high temperature, high pressure, you can see the temperature and you can see the pressure. 300 atmosphere pressure, very high. Temperature 623 Kelvin, very harsh condition. If you treat sodium hydroxide with chlorobenzene under this condition, it leads to formation of first phenoxide. This is called sodium phenoxide. Since our aim is substitution on acidification with dilute hydrochloric acid, it results in the formation of phenol. And this process we call Dawes process. And the Dawes process, when you treat chlorobenzene with sodium hydroxide and 623 Kelvin, 300 atmosphere pressure, followed by acidification, gives me phenol. Now, for 1 mark, we won't expect the student to write sodium phenoxide. So in the examination, if the question comes for 1 mark, how are you supposed to write the answer? You just write chlorobenzene, put the condition 1 followed by 2, understood for a teacher that there are 2 steps. First, you're treating with this, which on acidification will give you what? Phenol. Okay? So please do remember this. Next comes effect of the substituents on the reactivity of haloarenes. Now what will happen if the same reaction, chlorobenzene, if I substitute some hydrogen atom by some other group, and the group will be electron withdrawing. So let's see the effect of the electron withdrawing group on the chlorobenzene. It is observed that if the electron withdrawing group are attached to the haloarene, then the reaction becomes easier. The reaction can take place at lower conditions. And I can say it enhances the what? The nuclear. So let's take example. You have taken the orthochlorobenzene. When we say orthochlor, but this is like chlorobenzene. Nitro group is what? This, not a secondary, so we call ortho-nitrochlorobenzene. Nitro group is there, NO2, and NO2 will write like N with a double bond, with a single bond, negative charge, and the positive charge over the what? Nitrogen, because the fourth bond is forming here. So whenever nucleophile comes, attacks the carbon, both the electrons will shift to this carbon, leads to formation of negative charge. And you can see how resonance is taking place. So this resonance here of the negative charged electrons over the ring leads to increased stability. So when nucleophile attacks your orthonitrochlorobenzene, a carbon anion is formed. This is a carbon anion only, negative charge with the carbon. And then further delocalization of the negative charge over the ring take place. And hence it increases the stability. So nitro group, which is electron withdrawing group, helps in the nucleophilic substitution reaction. This same effect you will see in the para also. So you should know the mechanism, compulsory. Each one of you practice the mechanism. You'll be showing the delocalization of the electrons over the ring. Is the point got clear to everyone?
So what did you say?
You need to practice this. This is a very important ortho and para-nitrochlorobenzene substitution mechanism.
Okay, sir. So please upload notes.
No, that will upload. But you should know that how the reaction is taking place.
So the NO2 is only the withdrawing. It is only for withdrawing the electrons from
Correct.
the pi bond, right?
Yes.
Okay.
But when the same nitro group at the meta position, then the negative charge will not come on the carbon which is attached to the nitrogen. Suppose if the nitrogen you consider here, consider nitrogen here, and if a delocalization will take place, the negative charge will come here, and then the electrons will come, then this will come over this carbon. So the carbon which attached to the nitrogen at the meta position will not have the electron density. So which it cannot stabilize it. So nitro group only at ortho and para able to stabilize, but not at meta position. So we can say simply if the withdrawing groups present at ortho para increases the reactivity of haloarenes. And when withdrawing groups present at the meta, you can write no negative charge at the meta position in the resonating structure, due to which the presence of electron withdrawing group has no effect on the reactivity. All of you write on this is important. I'll repeat the statement again. Withdrawing group present at ortho and para position increases the reactivity. of haloarenes while at meta position there is no negative charge at meta position in a resonating structure and hence no effect on the reactivity. There is no negative charge at meta position in the resonating structure and hence no effect on the reactivity. I already explained in this answer. So when I upload this, you can study from here. Now, comes to the second reaction with metals like alkyl halide, Wood's reaction we know. Same case here, your chlorobenzene when treated with sodium and ether, it formed diphenylbenzene. So there we call Wood's reaction, here we got Fittig reaction.